Dear students, today we will explore a few crystal structure visualization software tools that are useful for academic as well as research purposes. These tools help us to get an understanding of various crystal structures, unit cells, various interactions in solid state, etc. What is the importance of visualization? Visualization is a key to crystallography. It helps to interpret the arrangement of atoms and unit cells. It helps to visualize different planes, symmetry and various types of packing in solids. It is also useful in X-ray diffraction and solid state chemistry. These visualization softwares also help us to produce publication quality images. Now let us see a few crystal structure visualization softwares. One is Crystal Viewer. Crystal Viewer is a very simple educational tool which is perfect for beginners. So this is a very simple tool that helps to view different crystal structures and it is very suitable for undergraduate students. So it is a simple 3D crystal display. We can see unit cells, different crystal systems, then lattice planes, etc. and it is very useful for beginners. Next one is Mercury. Mercury is a free software and it is one of the most popular free academic tools. And it is designed to handle CIF files, that is crystallographic information file, which is a data that we get from the powder X-ray diffraction or single crystal X-ray diffraction. So it is designed to handle these CIF files, and CIF files can also be obtained from the Cambridge structural databases. Mercury provides detailed information on different types of molecular packing and different types of interactions, particularly non-covalent interactions such as hydrogen bonding, van der Waals, etc. Another software is Diamond, developed by the Crystal Impact. Diamond is widely used in research labs for professional quality visualization. It is generally used for more advanced level structure analysis. It shows complex details such as coordination, polyhedra, symmetry elements, and it can generate high quality publication quality figures. And like in Mercury, Diamond can also handle CIF files and we can generate various crystal structures, can calculate the bond distance, bond angles. Similarly, different kinds of non-covalent interactions such as hydrogen bonding, pi-pi interactions, van der Waals interactions, etc. Now this is a paid software. There are other software tools that can be used for crystal structure analysis and visualizations. For example, JMOL. JMOL is a web-based interactive viewer. Similarly, we have Avogadro. So Avogadro is a molecular builder software. It also helps in 3D visualization of the molecules. Then we have Ovito, which is a simulation visualization software. Then XCRY is then, so that is electronic structure visualization softwares. So there are numerous other softwares as well which allows us to study, analyze, visualize different crystal structures and packing in solids. So, how to choose a particular software? Okay. So, choosing the right tool help us to get a better understanding of various crystal structures. For beginners, that is for students, Crystal Viewer is a very good option. It helps us to visualize the basic crystal systems, lattice planes, etc. Then Mercury, J-mol, Avogadro are all suitable for students. For advanced level, for more higher research level, Vesta, Diamond, Crystal Maker are all suitable. If you want to generate publication quality images or graphics, then you can opt for Diamond, Pi-mol, Mercury, etc. Now, let us get familiarized with a few crystal structure visualization softwares. First, let us look into Crystal Viewer. So, this is the interface of Crystal Viewer software. Crystal Viewer is actually a paid software, but you can download a free demo version of it. So, when you open this, on the left hand side, you can see a library of different crystal structures. So, you can see materials. So, on the materials tab, you have different folders like hybrid materials, inorganics, organics, etc. So, among the hybrid materials, you can see different types of clathrates, the crystal structures of clathrates. Then you have MOFs, metal organic frameworks. So, different types of structures. So, metal organic frameworks, on the right hand side you can see a short note on what are metal organic frameworks. So, these are the default crystal structures available in Crystal Viewer. Then these are the structures of different zeolitic imidazole frameworks. Again, these are metal organic structures, zeolites, imidazolate frameworks. Then we have different inorganic materials, for example, borates, different kinds of borates. So, this is barium sodium orthoborate. Then we have boracite, borax, which is hydrated sodium tetraborate. So, similarly, there are a variety of crystal structures consisting of borate. Similarly, we have amides. Okay. So, this is lithium imide, and this is another material consisting of lithium and boron, and this is lithium amide, sodium amide or sodamide NaNH2. So, similarly, you can see different varieties of crystal structures. So, besides these, you can also see different types of oxalates, calcium oxalate. These are different types of oxalates. For undergraduate students, we have learned about different crystal systems. So, in Crystal Viewer, you can see the 7 crystal systems. So, this is the cubic system, We know that the cell parameters A equals B equals C and alpha equals beta equals gamma equals 90 degree. Then we have a hexagonal system, a hexagonal unit cell with a gamma equals 120 degree. Now this is a monoclinic unit cell and this is orthorhombic with all sides unequal, A not equal to B not equal to C, and angle alpha equals beta equals gamma equals 90 degree. Now this is another crystal system, that is the tetragonal system. This is a triclinic system with none of the sides and angles equal, that is A not equal to B not equal to C and alpha not equal to beta not equal to gamma, and this is the trigonal system. So you can visualize all these 7 crystal systems in this software. Then here we have lattice types. We have the 14 Breve lattices. Okay. So we have the simple cubic. So this is a face centered cubic lattice. You can see the atoms at the corners as well as at the centers of each face. Now this is a body centered cubic lattice. You can see atoms at the corners as well as at the center of the body. This is a primitive cubic lattice, that is atoms present only at the corners. Now here you have a primitive hexagonal lattice and this is a monoclinic cubic lattice and this is a primitive monoclinic lattice and this is a orthorhombic lattice. Here this is a face centered orthorhombic lattice. This is a body centered orthorhombic lattice and a primitive orthorhombic lattice. In this you can also see a rhombohedral. This is a special kind of lattice with 3-fold symmetry, and this is a rhombohedral present on a hexagonal axis. Then we have the 3 tetragonal cubic lattices. This is a body centered tetragonal lattice, a primitive tetragonal lattice, and this is a triclinic lattice. Okay. So 7 crystal systems as well as 14 Breve lattices can be visualized in this software. Then the next option is lattice defects. So there are different types of defects occurring in solids due to the presence of impurities or the presence of vacancies, etc. So the main defects is the Schottky defect, then the Frenkel defect. So all these can be seen here. We have a screw dislocation, edge dislocation. So all kinds of defects occurring in the packing of solids can be seen using this software. Next is different types of polyhedra, okay, which is an indicative of the coordination groups in different materials. So you have a cube, and on the right hand side you can see the number of vertices, faces and edges given. So this is a cube octahedron with 12 vertices, 14 faces and 24 edges. This is a dodecahedron. It's an icosahedron. So similarly, all kinds of polyhedra. You can see so much interesting structures of different types of polyhedra here. So when you click on that, you can see a write up on the right hand side. So information can be obtained by visualizing these structures as well as by seeing this note given at the right hand end. Then we have building crystals. So you have different options here. So this is a tutorial on how to build crystals. Okay. So here they have given different types of packing, mainly hexagonal close packing and cubic close packing. So, this is a demo version. So, we can just observe these kind of packings here. These are the examples of some ionic structures. This is a structure of zinc sulfide. It's a wurtzite structure. So, this is another form of zinc sulfide, sphalerite. We can also see the crystal structure of sodium chloride, that is the halite structure. Okay. So, this is here you can see the space filling model, and this shows the interpenetrating FCC lattices in NaCl. So, similarly, almost all types of crystal structures, whether it is ionic or whether it is covalent, you can easily observe using this software. So, this is the crystal structure of diamond, and this shows the crystal structure of graphite. Next is the silicates, which contains SiO4 tetrahedra. Different types are given, mica, quartz, all these can be seen here. These are some non-silicates. So, this is a calcite crystal. This is hematite, Fe2O3, and this is a spinel structure consisting of Al2O4 or Mg. O4, it's a spinal structure. So, similarly, different types of structures can be seen. Different zeolite frameworks that we have already seen. Then on the left hand side, you can see numerous subdivisions like agriculture, asbestos, battery material, biomineral, etc. So, let us see, when we click on agriculture, you have 3 folders: fertilizers, herbicide, pesticides, etc. So, let us see what inside fertilizers. You can see crystal structures of commonly used fertilizers like KNO3, Sylvite KCl, etc. Crystal structures of this. Then under herbicide, commonly used herbicides like Agent Orange, glyphosate, etc. So, this is the crystal structure of pesticides. You have DDT, DEET, etc. So, here then if we click on the battery materials, commonly used materials in battery based on lithium. So, you can see different structures. Explosive, when we click on explosive, you can see a list of chemical explosives. This is 2,4,6 trinitrotoluene, this is cyanuric triazide, then nitroglycerin, RDX, sodium acide. So, you can see beautiful crystal structures of chemical explosives that we commonly use. So, similarly, there are a lot of options. Then if you click on food, you can see the colorings, food colorings that we use like citrus red 2, erythrocin, sunset yellow, fast yellow AB. So, all these structures can be seen. When we click on flavorings, 3-methyl butyl ethanoate, phosphoric acid, rose oxide, eugenol, ethyl cinnamate, all these are commonly used flavorings in food. Then you can see food preservatives, dodecyl gallate, sweeteners used in food like aspartame, fructose, glucose, sucrose, etc. Here under phase transition, you can see different crystal structures. So, this is albite under pressure behavior as well as under temperature behavior. Then you have perovskites. Similarly, the phase transition in quartz can be seen. In medicine, a lot of crystal structures used in the medical field or biomolecules like ibuprofen, halothane, insulin, morphine, paracetamol, penicillin, etc. So, there is a large collection of a variety of crystal structures related to almost every field. So, whether it is in the industrial field, in agricultural, in medicine, as explosives, in food, that is as colorings, flavorings, preservatives. So, you can see a large variety of crystal structures of almost all compounds that we use in daily life. So, this software is a very good option for understanding and visualizing the crystal structures of different compounds that we commonly use in daily life. Okay. Another software that is used for crystal structure visualization is Diamond, and this is a paid software and it is generally used for advanced level crystal structure analysis and for analyzing various intermolecular interactions, calculation of bond distances, bond angles, etc. So, when you open this software, so go to File and there is a library which shows the crystal structures of various crystalline solids. So, give open. So, in this there is a folder called samples. So, samples, select minerals. So, you can see a list of minerals. So, these a wide range of minerals can be seen. So, let us select anatase, which is a polymorphic form of TiO2. So, when you give open, so you can see the anatase. Okay. So, on this bar there are a lot of options. So, this is the selection mode. If you want to rotate this, click here. This is rotation along the x and y axis. So, you can rotate this for easy visualization. If you want to rotate along the z axis, so that is also possible. If you want to zoom, then you just click and scroll the, so this is the zoom button. So, this is the anatase phase. Then you can visualize this using, so this is the wire frame, wire model. Here when you click, this is the ball and stick model. This is the space filling model, okay. The space filling model. So, in what way we want to visualize, you can use that. There are a lot of other options as well. So, this is the default structures available in this software. Now, let us open another structure. For example, bruchite. Bruchite is another polymorphic form of TiO2. This is the bruchite phase. See the difference in the crystal structures. the brookite phase. If you want to add the angles, you can click here, axis. Now let's take another mineral, corundum. So this is the crystal structure of corundum or Al2O3. So this is the wire model. This is the ball and stick model. Let's take another structure. Let's see the structure of diamond. So here you can see the crystal structure of diamond. You can even change the color of the atoms. So to change the color, we may click on a particular atom. So you can select that atom and then you go to edit, then atom types. Okay. So here you can see, so select design and you can give the color. So instead of gray, you can select any other colors. So if you want to give it a green color, so you can select green, or you can a yellow color, then you can select yellow. Okay. Then give OK. And here the style, you can either give it as a solid or a globe or crescent or shadow, any style you can choose. Click OK. Now you can see the color of the atoms has changed to yellow. So in a similar way, you can customize this structures, and if you want to see it in a wire frame, so like this, it will be like this. This is a ball and stick model. If you want to see diamond in a space filling model, so this is a space filling model of diamond. Okay. Now let's see another structure. So we have graphite. So you can see a beautiful layered structure of graphite. Graphite is also an allotrope of carbon. So this is the layered structure of graphite. You can change it. So this is a space filling model of graphite. It is better to visualize this using this ball and stick model. So you can easily see the layered structure, hexagonally packed layered structure of graphite. So similarly, there are a lot of crystal structures of various minerals given here. We have the structure of halite, sodium chloride. Okay. So this you can see as a beautiful polyhedron faces, and this is the crystal structure of halite consisting of two interpenetrating FCC lattices. So diamond is an excellent software which allows the visualization as well as the interpretation of various crystal structures. Let's see one more polymorphic form of titanium dioxide, that is the rutile phase. We have discussed in the previous class the three polymorphs of titanium dioxide. So this is the rutile form, which is the most thermodynamically the most stable form. So this is the crystal structure of rutile. So apart from this, there are a lot of other applications. So, diamond can read, as I said earlier, it can read CIF files. So, if we have the CIF file of a particular crystalline solid, we can open it in diamond, we can generate the crystal structures, that is build up the crystal structures, we can identify the bond distances, bond angles, then analyze various interactions such as hydrogen bonding interactions, pi-pi interactions, etc. So, the application is very vast, and this diamond software is generally used at an advanced level purposes, mainly for research purposes as well as for producing high quality publication level images. Okay. So, now let us look into one more software, that is Mercury. So, Mercury is a free software, you can you can download it from the CEC-UGC website, and it is purely used for academic purposes. So, this is the interface, and if you go to File, then click Open. So, when you click Open, so go to the program file Mercury, double click. So, you will have a lot of folders coming in. So, if you click on, for example, hydrogen bond coordination model. Okay, so this is again a library of different structures. You click on examples and you can select Mercury files. So, this is a demo. So, you can here you can see hydrogen bonding interactions in this. The dotted lines shows the hydrogen bonding interactions here. So, here you can see another crystal structure in the wire frame. So, if you want to change the style, here there is style option. So, if you click ball and stick, so you can see the ball and stick style. We want to see the space fill model. So, this is the space fill model. Again, this is a polyhedral model. So, let us try to open a CIF file. Okay, so this is a CIF file. So, we have selected CIF file and then we try to open. Okay. So, this is actually a transition metal complex with 4 pyrosol rings. So, one advantage of Mercury is that if we open the CIF file in this, and at the lower end you can see there is an option called powder. So, if you click on this powder, then you can see a simulated powder pattern generated based on the crystal structure of the solid. Okay. So, this is a simulated powder pattern. So, when we place this mouse on each peak, you can also get the HKL value, that is the Miller indices value. The Miller indices value are shown at the bottom right corner. Okay, so, here it is the Miller indices value. So, when we keep this at the most intense peak here, okay. So, this is a 1 1 0 plane, So, here you have 3 ones, 2 2 0 plane. So, this is a 1 1 1 plane. So, you can index each diffraction peak. So, you get a simulated powder pattern for this crystal structure. So, using this simulated powder pattern, we can compare it with the experimental pattern and identify, that helps to identify different phases, planes, etc. Okay, so, that is one advantage of mercury. So, here the x axis it is 2 theta and y axis it is intensity. So, you can mark the HKL planes, etc. Along with that, you can also calculate the bond distances, bond angles, etc. So, if you click on hydrogen bond, it shows the hydrogen bonding interactions given as red dotted lines here. There is a zoom option here. So, if you click on this, this can be enlarged, zoom in and zoom out options available. You can change the style, as I said earlier. If you want an ellipsoid form like this, a wireframe model is like this. This is a capped stick model. So, based on our preference, we can customize the appearance of these crystal structures. So, this is the space fill model. So, a variety of options are available in mercury. So, another option here is if you click animate, there is an option called animate at the top end corner. So, you can see the rotation of the crystal structure. You once more click on animate, there is an option called oscillate. So, if you give oscillate, you can see the oscillation of the atoms. Here you can see the oscillation, and this is the rotation. So, mercury is a very good software to visualize various crystal structures, to understand various interactions such as hydrogen bonding, pi-pi interactions. You can easily generate a simulated powder pattern from the CIF file, that is the crystallographic information file obtained from the Cambridge structural database, or the CIF file obtained from the single crystal data. Okay. So, these are few crystal structure visualization softwares that help us to visualize and learn different crystal structures, calculation of lattice parameters, understand packing in various solids, etc. So, try to explore some free crystal structure visualization softwares and have fun in learning crystallography. Thank you.